Good day, everyone, and welcome to the first webinar of EHDEN project. Today we'll be talking about the Study-a-thon, which was held end of last year in Oxford in the EHDEN project. My name is Kees van Bochove, and I'm the CEO and founder of TheHyve. I have a background in building health data infrastructures and networks, going back a few years in the Netherlands with the CTM Trade project, several other health networks, and also now EHDEN, which is a European network. Today we have with us Professor Daniel-Prieto Alhambra for the University of Oxford. And maybe we can start, Danny, by having you introduce yourself to the audience.
Sure. Good afternoon, everyone. So I'm Daniel-Prieto Alhambra. I work at the University of Oxford as a professor of pharmaco and device epidemiology, and I'm also the theme lead for observational research at the Center for Statistics in Medicine at the University of Oxford. I'm delighted to be here.
Right. Yeah, thank you for joining us for this first webinar. There will be more webinars in this series. The next one will be in April 10, which will actually feature the leaders of the project, which are Prof. Peter Rijnbeek from Erasmus MC. Peter is an expert in applying data science to healthcare data, and also Nigel Hughes from Janssen, who is very experienced in applying this in the process of using medical evidence to inform drug development and also other means of, for example, devices. We'll be looking in EHDEN not only at drugs, but also devices and other medical treatments. Today, we'll dive into a specific example, which actually stems from Danny's practice. Danny, you are also a treating clinician, are you not?
I am indeed, yes. I am, as I said, an academic clinician, and I work in a rheumatology department at the Oxford University Hospitals Trust. So I see every Tuesday, I see a short list of patients.
Yeah. So what I would like to find out from you really in this hour that we have is how exactly a project like EHDEN and all the things that we're doing in healthcare data, working with OMOP, etc., can help in the end the medical practice. Because that's what we're all here for. This is why we're in the project. So can you maybe explain from your perspective, you know, you do research, you also treat patients. How do these two interact?
Well, research informs clinical practice, or should inform clinical practice at least all the time. It informs clinical practice in a number of ways by providing us the tools to identify patients at risk of having any given health problem, so we can try and prevent that health problem. I guess you can think of conditions like diabetes or hypertension where we use those tools all the time. It helps us by informing on which medications are effective at preventing or treating a given health disease. So we use mostly for that randomized control trial data where people are given one treatment or another by chance, by random process. And more recently, in my particular area of interest, we have been learning a lot from routinely collected data, from real-world evidence, as some people call it, on who is using these treatments in the general population, not in research settings so much, and what happens to those people when they take these medications or they receive these surgeries.
Right. So you mentioned randomized controlled trials. The classical way of, let's say, applying science to medicine is indeed really that, right? So from a statistical viewpoint, what we want to know is what is really the effect of the intervention that we are introducing, be that a device or a drug. And RCTs, in a way, are the gold standard still today to produce evidence. Would you agree?
I would agree. Yeah, I think they are the gold standard to provide evidence on efficacy, at least, which is the proof of concept you need to demonstrate that a given intervention works, at least in a controlled environment, as it is that of a randomized controlled trial. So I think that's the current practice, I would say, worldwide. At least for medications, we need randomized controlled trial data before a medication can be approved for human use. And then a different issue is when that medication is being used in the general population. people who take medicines in the real world, in actual practice conditions, are not necessarily similar to people who participated in those pivotal randomized controlled trials, and hence the need for real world evidence or for routinely collected data and related research.
Right, right. So just to explore that a bit further, also for the viewers and the audience. So you have RCT on the one hand as a gold standard. What you're saying is it's also important to go into observational research. And one reason you cite is that the typical patient in an RCT doesn't actually look like the typical patient that walks into your practice. But why is that? Can you give us a flavor, some examples of how that's really different?
Yeah, I guess I'll just add to that obviously there are different RCTs, and there are more pragmatic ones that attempt to mimic the kind of real world scenarios. And there are others that are more controlled and probably have more restrictive criteria, and those tend to, maybe depart a little bit more from the actual practice setting. Yeah, the reasons why RCTs can be sometimes compromised in terms of external validity, as we would call it, have to do basically with the use of very particular settings, very controlled, very well controlled, and restricted areas of clinical practice. So, randomized controlled trials tend to happen in academic institutions with a lot of expertise in the conducting of such studies, in a very well-controlled environment where everything is measured to the detail for obvious reasons. And that is, of course, very different from what happens in the real world. That's when it comes to the kind of healthcare context, if you like. When it comes to the patients themselves, there are, as I said, some randomized controlled trials that are considered more pragmatic and attempt to create a population that's more similar to the one that will be treated with the medication once it hits the real world. But there are trials that maybe at a more earlier stage tend to include patients that are very different, very special, or very, very, in a way, very pure in terms of research. So they haven't been exposed to other medications, who don't have too many conditions, people you make sure, or you try to make sure, will come back to the next appointment, so you can measure what's going on with them when they are on the treatment. And that is what doesn't really look that much alike what happens in real world or in actual practice.
Right, right. So one of aspect that sometimes is called out as a difference is comorbidities. So there is this lab in Denmark run by Søren Brunak. I know you may have seen some of these papers and results. It's very fascinating because they visualize how patients progress in the real world, looking at the diseases that they get over time. And very often you see there are multiple diseases. Would you say that is also something that's harder to capture in an RCT? Is that a problem, or how does observational research come into that?
Well, observational research, I guess, is more problematic, or people are more critical of it when it comes to comparing different treatments and their efficacy and safety and so on. When it comes to observing something as it happens in the population, I think that's where observational research is probably the first line gold standard. If you are interested in learning who is using a new medication that has been launched in the market, what you have to do is get hold of people who are out there in the street and get real world data to measure that, right? If you're interested in learning the patterns or the kind of secular trends or trajectories of comorbidity, again, you want to go out there and get hold of a representative population. And these kind of routinely collected data are brilliant for that.
Yeah.
Very useful.
Yeah. Okay. So we may come back to this topic later, but for now, I'd also like to quickly zoom in on something else. In the title of this webinar and in the announcements, we've talked about open science. And when I was at the OHDSI meeting last year in Washington, and also when you presented the Oxford Study-a-thon, I was struck by the emergence, let's say, of science, where a number of people come together, in the case of the Study-a-thon, for just a few days. They bring with them expertise and knowledge, but they also do some research that is very hard to do just from your desk, collaborating together. And this is what I'd like to zoom in now So could you maybe explain the concept of a study-a-thon and what did you do there in Oxford?
Yeah, so this study-a-thon that has happened in the past in the US, and as far as I'm aware, happened for the first time in Europe last December in Oxford, is a very interesting socio-technical experience where people from different backgrounds with different skills sit in a room or in more than a room, ideally, for a week or so and try to answer a very relevant clinical question from, kind of nailing the research question itself to having a final answer, even written up in the form of a manuscript that aims to be submitted to a journal in the following few days. So it's a very intensive experience where people, as I said, with very different knowledge and skills work together to make this happen in a very short time frame with very advanced tools that have been previously developed. So you don't, you are not really programming from scratch. You are not mining data that's not been structured. You are using tools that have been used before and validated for that purpose.
Right. Yes. So I'm a big fan of open science and also of the fair data principles. In fact, a couple months ago, I had a conversation with Ruben Kok from DTL about open science, about the FAIR principles. And really, if you sort of zoom out, the difference between the classical scientific approach, where I come up with my hypothesis, then I design my experiment, I conduct my experiment, I do my analysis, I finally then publish my results. In open science and with FAIR is transformed into a process where, as a scientist, I can do any one of those things and become really, really good at it. But what that means is that if, for example, if I only want to focus on analysis, I need to find the data to analyze, right? And this is the difference where if you go in a 21st century open science networked approach, you really need to help each other, not only, in the research and reading each other's papers, but actually working with each other's data. So maybe to explain and illustrate it a bit, could you give us a flavor of the skill sets that are needed and the data that are needed to answer such a question?
Definitely. I guess if I may go into one of my slides. So this is the kind of skill set that we thought we needed for this particular research question that we were trying to answer with this given list of data sets that we used. So we thought, because we were looking at knee replacement surgery, we needed someone with some clinical knowledge of the issue and what are the important research questions around that. So there were some clinicians in the room helping with that, including myself. There was need for knowledge of the UK primary care data that we were using called THIN, and we had some colleagues from IQVIA that were present that week and helping us out to tease out the kind of codes that were used by GPs and so on and so forth. We needed in knowledge knowledge on the US claims data that we were also using during the week, and we had colleagues from Johnson & Johnson who were very experienced with the use of that data. Obviously, we were using the OHDSI tools to analyze a number of research questions. And again, there were people in the room who had a lot of experience with that. There were some tweaks that we need to apply to some R programs, and that kind of skill was also very welcome. And finally, even for people who didn't have any of the backgrounds above, we thought that we also needed, because obviously you want to communicate the research that you conduct, people, with the knowledge, the experience, and the willingness to write this up in the form of a publication, of a manuscript, and a number of scientific abstracts. And we also had that sort of people in the room. There were a total of 40 people in this study-a-thon, and coming from all over Europe, and a handful of them from the US, helping out with the different bullet points in here.
Yeah. Okay. So why did you come up with the topic of knee replacement? How did that happen?
So I guess mimicking what had happened in the past in the US, what we did was we opened for registration, and once we had the list of people who wanted to contribute, they were sent to a forum, and they had the opportunity to put in there some research questions that they thought were interesting. We then ranked, had a look at them, and and ranked them based on feasibility. And we ended up with a number of research questions we thought we could answer with the data we had access to. And then that was put up to a vote by the people who were participating in the study-a-thon. So people said what was their preferred research question, and then we went for the one that was felt most relevant by the audience or by the colleagues who were joining the study-a-thon. So it was, again, a community exercise where we all voted, and we ended up with this research question.
Yeah. So when you say relevant or clinically relevant, what does that mean exactly?
Yes, I guess I'm sure there are formal definitions for this, but the way I understand clinical relevance is that it answers a research question that hasn't been answered in full or not, let's say, substantially enough. So wherever there is a gap in the existing evidence. In this particular research question that we went for, we knew there was an ongoing randomized control trial trying to answer this research question. That trial will publish in the coming few months because it's closed already, but it hasn't been published yet. And then we tried to, in a way, predict the findings from that trial, and then also complement that trial with some additional data on things that the trial will not be powered to look at, like rare events like complications and rare safety outcomes.
Oh, that's interesting. So what's the name of this trial?
So this trial is called Topcut, which stands for Total or Partial Knee Replacement or Knee Arthroplasty Trial. And the colleagues in my department from the Surgical International Trials Unit have been leading it for the last 5 years or 6 years.
Right. When you say 5 or 6 years, you literally mean that the trial takes that long?
The trial takes longer than that, probably because they had to obviously get funding for it and get ethics approvals and all that. But the follow-up in total was of 5 years.
Okay, but when you say that during this study-a-thon, I mean, it's what a lot of people, but it's only 5 days. Mm-hmm. You can predict the outcome of this trial. What does that mean, really? Is it just like it may be successful in predicting the outcome, but we're not really sure about the observational data? Or would you even go as far as say that we wouldn't technically need this trial because we can be confident just looking at the observational data about the validity of the conclusions? Like how bold can you be when you say we can predict the outcome of this trial?
So I guess the aim was to predict the outcome of a trial, but because the trial has not been published, we don't know whether we have succeeded at that. So I don't want to be so bold.
Yeah.
There are a number of ongoing studies trying to predict. I don't think predict. Most of the studies that I've seen, observational studies, are trying to replicate previously published trials. There's been a lot of literature on that. Some success, some failure. I guess for a number of reasons, including methodological aspects and also the quality of the data used. But yeah, there are mixed experiences with the attempt to replicate a randomized control trial. I would not say that we don't need trials. I think we do need randomized control trial data before we approve, for instance, medications, as I said earlier, because well, for starters, they are not available in clinical practice, so you cannot find anyone using them in routinely collected data, right? But I think we are, in a way, learning over time to use, to the best of our knowledge and to the best of the possibilities, these routinely collected data to make research more efficient. And there are things that just cannot be answered with a trial. Like, for instance, this trial that I'm mentioning had, in total, I guess it must be around 1,000 patients. That is not enough to look at rare complications like postoperative, blood clots or infections, because they are rare, and you need bigger data than that to answer that. So I think trials and observational data will most likely continue to work together to provide the best clinical answers to the questions we have in clinics.
Right. So just as a quick intermezzo to our audience and viewers. If you do have any questions to Danny or to me about RCTs versus observational research or about the study-a-thon, please feel free to ask them. We will definitely try and answer them as they come in. In the meantime, Danny, it would be nice to maybe get a bit more flavor of how such a study-a-thon actually works. Like, what do you go through? It's a lot of people that come there and they have day jobs, right? So they must be, I guess, really seeing an advantage in there. So can you take us through how such a study-a-thon works?
Yeah, so I guess if you're asking me why people came, you would have to ask them.
Yeah, yeah.
But I guess people found it, as I said, a very interesting experience. They had the opportunity to learn something hands-on, so doing it rather than listening to someone talking. So that was quite interesting as well. It was, I guess, a very good opportunity for people to network as well and to do something clinically relevant together for a week. And people just, they registered and came to the meeting. If it is interesting, I can tell you a little bit about what we did during the week. So this is the agenda that our colleague Patrick Ryan put together for the week and that we agreed together. Basically, the first day we spent having a final consensus on what was the clinical problem we were trying to answer, defining who were the cohorts or the populations that we were interested in studying, and operationalizing that a little bit. So putting that into lists of codes and the way that this data works, right? So we were just attempting to create the cohorts that we wanted to study, and we did that together with all the colleagues in the study-a-thon. On the second day, we looked at what we call characterization. So we basically looked at the characteristics of those patients that were participating in this study. And then we started writing up a plan and a protocol that we shared online with all the colleagues in the room on how we would set out to predict the outcomes, because on top of comparing the two types of surgery, as I mentioned, we also did something else during that week, which was trying to predict who would get any of the complications. So that, if you found, for instance, that one of the surgeries led to a lower risk of complications, you could potentially offer that type of surgery to people with a lower risk, right? Sorry, with a higher baseline risk, to try and minimize that risk. So we had the kind of comparison that we call population level estimation, and then the population level patient level prediction, where we were trying to predict who was at risk of these outcomes. So already on the second day, we were drafting a protocol and a paper on the prediction problem. On the third day, on Wednesday, we started. We went already into the results obtained for the comparison of both. For the prediction of complications. So we had preliminary results. We went through them. We looked at the validity of the prediction tools that had been created, and then we externally validated the valid models in other data sets, because that's one of the beauties of this exercise, that by using this common data model and using these analytical pipelines that we will also have available and will increase in EHDEN, we managed to not only create a good prediction model, but also validate it in different data sets to make sure that actually the model was transportable to different populations. On the fourth day, that's Thursday, we then looked at the design and the nitty-gritty of the design of the population level estimation, so the comparison of partial versus total knee replacement. And then we started looking at the diagnostics of the models that we wanted to feed to minimize confounding and to make the groups as comparable as possible. And then on the final day, we basically looked at the results from that bit, and we finalized the kind of allocation of tasks for people to complete in the following days to get papers submitted to journals in the following week or two.
Right. Great. Thanks for the overview. I'm going to come back to that in a minute, but we also have some questions from the audience, which I'd like to pose to you. So one question that we got is, what will you to say to the Topcut study principal investigators or PIs if you replicate their results?
Well, I guess there's a list. The primary outcome of the trial we cannot replicate because it was a patient-reported outcome, so it's something that we wouldn't have available in these routinely collected data sets. If, let's say, in another trial, not Topcut, where we had access to the primary outcome, if we managed to replicate the trial in such a quick way, well, I would have been quite impressed, and I guess I would discuss that with the principal investigators. And I am a strong believer that, as I said earlier, trialists and people who do observational research like myself need to work together to make sure that basically we use the best and most efficient tools available to provide clinical answers in a timely manner. So if we were confident that in some clinical scenarios we can overrule trials, we should do that. I am not convinced that is still the case, and I'm not sure we can be so bold to say, let's just skip trials and go straight for observational data.
Right.
As I said earlier as well, in most of the situations, you will need randomized controlled trial data first because, products and drugs don't make it to the market until they have been approved in a randomized controlled trial setting, right? So
Yeah.
you will not have any people using those medications until the medications have been approved, and that requires randomized controlled trials.
Sure. Yeah. Okay. But I think in true open science fashion, you already put the results of your analysis online on the internet, right? And we may get a chance later to look at that in more detail. But did you also try and attempt publishing these results in a journal even before the Topcut results are published?
So we wrote a paper that went to the New England Journal of Medicine. As you know, this is one of the top journals in the world. They accepted it for peer review, which is something because they only accept a handful of papers, and they rejected it recently, and we will be resubmitting very soon. But I guess the challenge here was not to publish in the top journal in the world, but to get this data out there in a good journal in the coming few weeks. And, the earlier the better. And if possible, before the trial publishes, so that we can certainly say that, we blindly predicted the trial or not. And if we don't, because we didn't get that question from the audience, but that's probably even more interesting. If we don't replicate the trial, then I think there's a need for us to sit down again with the people who do trials and with other stakeholders, I guess, and to understand why that happened and see where our data can be more useful than the trial data and where the opposite is true.
Right. There's also another question from the audience, which is asking if we are planning to do any future study-a-thons, possibly also in other areas and with other questions.
So I guess the answer to that should come from the webinar that Peter Reinbeck and Nigel Hughes will hold very soon. But I'm hopeful that will be the case, and certainly if there's another study-a-thon, I will join it because I very much enjoyed it. About the research question, as I said earlier, I hope that again it will be the same and people will be voting on a research question, and I'm sure that it won't be the same. It will be something else.
Yeah. So more questions are coming in. Maybe take this one. Have journal publishers been receptive to the paper you submitted, and in particular the methodologies?
So as I said, our paper went out to the New England Journal of Medicine, which is a journal that, if you look at the latest issue, you'll find out very quickly it basically publishes randomized controlled trials and big ones. So even smaller trials don't even try to publish there. And the fact that the editors considered it for peer review internally was quite an achievement, I thought. When one looks at the peer review that we got, there were a couple of reviewers that were concerned about let's say, the detail of the analysis that I think we could have convinced with further analytics. And there was one of them who basically was having a go at observational research altogether and saying, this is observational, therefore it doesn't merit any publication. That happens, and that's something we need to learn to live with. I think the readership of the New England Journal of Medicine and of other big journals are clever enough to judge what's good research and what isn't. And I'm hoping that this paper will get published in a nice journal very soon.
Yeah. There's another question. I'm not sure if you want to take it or how, but how do you control for biases and ensuring internal validity?
Yeah, so this is a whole area of research, right? And this is what we call pharmaco and device epidemiology. Is basically about using observational data to look at a number of things, but one of them is the comparative safety or effectiveness of medications used in large populations and ideally in real-world practice. So there are a number of methods out there. What we use for this particular study-a-thon, and I guess we'll have an opportunity to go through the details in a minute, was something called propensity score matching, which is basically a method that attempts to create comparable groups of users of one drug and another, in this case, recipients of one surgery and the other. So that's the kind of method we used here. It's a kind of, I would say, amongst the most popular methods in pharmacoepidemiology. There are others, and there are people who defend some and not others, and there are situations where one might perform better than the others. But that's what we did in this particular scenario.
Yeah. Do you need to do any filtering, or do you just consider all the data that you have in the study-a-thon?
So in this study-a-thon in particular, because we were attempting to predict the findings from a trial, we looked at very carefully at the inclusion criteria for the trial, because we wanted to make sure that if we found different results, it was not because we were looking at a different population, right?
Yeah.
So we basically excluded the patients that would have not been eligible for the trial.
Right. Yeah, there was also a question about whether we need more data for observational research. I think that is almost obvious from, it's one of the defining characteristics, if you will. But can you say something about it? Like, how much data is enough if you really want to consider doing an observational research study?
So there are, I think, a number of considerations for that. One of them is obviously the statistical power that you need will depend on a number of things, including, how many people are exposed to your drug or surgery or procedure of interest, and how many people have the outcome of interest. So those will be like the key parameters you need to consider when you power in terms of statistical power. I think what's really beautiful in this study-a-thon, and what will be great when we have data mapped to this common data model in Europe through EHDEN, is the opportunity to replicate the analysis from observational data in different data sets, because each different healthcare system, each different observational data set has different potentially different limitations, different healthcare settings. And then, if you are able to replicate the study in a number of different data sets, that is very robust, that's very strong. So that's the kind of second part of how much data you need, right? So I think you need data to cover your statistical power, but also, ideally at least, a number of different data sets to show how robust your findings are. If you obtain completely different results from different data sets using the same statistical analysis, the same common data model, you are probably, fighting against confounding and other issues.
Yeah. So that's another key element, I think, of observational research, right? That you do the same study, and I think this is also in the OHDSI community one of the focus. You do the same study in different databases.
Absolutely.
Yeah.
And not only you do it in different databases, because you can do that in a number of ways, but also you do it using exactly the same code, exactly the same common data model. So data that has been previously mapped to a common data model. So you can go from data management, data curation, all the way through to data analysis using exactly the same piece of code.
Right. There's so much to unpack here. People are asking questions about the open science angle, about how this works together, also on the medical part. But maybe just for a minute, going further on what you mentioned about the OMOP common data model. So to explain to the audience one of the bases of how we can do this in the OHDSI community and also in EHDEN. The healthcare databases typically contain data of patients, and of course, data on patients in general always takes a certain form. People will be taking drugs. There will be conditions observed. There might be procedures performed, and also several measurements that could be done in the lab. And what OMOP does is that on the one hand, it has a data model, which is just a prescribed way, a set of tables on how you should record this data. So if you have a drug treatment, there is a way in which you should model that. And this helps to make it comparable. We call that the syntactic harmonization of data. The other part of it is the semantic harmonization of data. So within the clinical world, there are several taxonomies or coding systems. For example, for measurements, there is LOINC. For conditions, you have SNOMED CT and ICD. For drugs, you have Rx norm, etc. And so the other part of OMOP and OHDSI is actually to align the data from the databases using these same terminologies or vocabularies. Maybe with that basis, you actually use this in the study-a-thon to be able to perform exactly the same analysis in the different databases that you had. But in order to do that, these databases needed to be in OMOP already, correct?
Yes, indeed.
And there's work to be done from the source data to OMOP. So are we not losing any, are we losing data in that conversion? Can you say something about how that could potentially affect your research?
Yes, I guess for the study-a-thon, we had data that had been previously mapped, so we didn't really experience that. We used data that had been mapped by colleagues from Johnson & Johnson, as I mentioned, and also for two of the data sources that we used, data mapped by IQVIA. So we had the data already in the final format. We didn't have to do any mapping. I guess there's plenty of experience with this, and other colleagues can speak about it better than I do. There are some situations where I guess when you are mapping, I know a little bit about the experience of colleagues from CIRIAP in Spain or colleagues from IPSI here in the Netherlands, where the mapping exercise is on its own a kind of data characterization exercise, because you find out things that are in your data in a format that can be surprising initially, but that helps you understand the structure of your data, really. And you can find, I remember the example of some prescriptions for, I think it was incontinence packs or something that, were initially classified as drugs in the source data, but then obviously when you mapped, couldn't be mapped as drugs because they are not drugs, right? So I think it's actually a very interesting exercise, and I prompt anyone to contact the colleagues that have been mapping their own source data before. I guess something that's quite relevant here and will be relevant for EHDEN is that the way we will work within EHDEN with map data is a way in which data will stay at source, and we will generate an ecosystem for these kind of studies to happen rather than accessing data remotely, initially at least, right? So the idea is that people can have their own data mapped to OMOP, and then they can choose to collaborate in a study once they are sent the code that we are testing in a different data set. So this enables a federated kind of structure where you can analyze data in a number of different places. And indeed, during the week, something that I found fascinating is that some colleagues from a couple of countries, I think it was South Korea and in the US, went to the OHDSI forum and got hold of our code and replicated the analysis, some of the analysis in the data. And that was a kind of fascinating exercise, because overnight, pretty much, people were able to go, from the source data or the map data, but in the kind of raw format, right, all the way to the final results to contribute to our findings.
Right.
And that is, I think, a game changer.
Yeah. Actually, let's give the audience a bit of a flavor for that. Because you put out, I think it was during the study-a-thon that you put out a question on the OHDSI forums, right? And you actually got a real-time response from people across the world.
Yeah. I guess we could have a quick look at that if you want.
Yeah, because open science is all about things being available on the internet. That's one of the reasons I'm always so excited about it, is you can actually see for yourself.
Yeah, so basically our colleague Patrick Ryan, who was co-leading this study-a-thon with us, basically put this question into the forum. He put the definitions of the cohorts up already in the OHDSI forums, and as you can see, people started ducking in from South Korea, and other people from other places were responding, and day to day he was giving an update on what we were up to, and basically feeding back to the people who were interested in participating. And there were, as you can see, other people from Columbia University, for instance, who were able and willing to replicate the analysis in their data. And as I said, some of them said, like South Korea, I think it was, they couldn't respond to this particular question because of the data they have, the nature of the data. But the colleagues from Columbia University, for instance, and also from Stanford, I think they replicated one of the bits which was about prediction modeling.
Right. So maybe to add on the dynamics of that, and also bringing in another question from the audience, you could see this study-a-thon just as a way to get focus from several people which have all their own disciplinary knowledge and their own expertise together to focus on this question. So would you say that that's an important reason why you did have a physical location, or is this also something that now there's the concept and the network, you could actually just do it remote
Yeah.
or in a network?
So to me, most of my research team was present in the study-a-thon, as you can imagine, and to me it was a very enriching experience. I think it was great to see people basically, taking ownership and working on a particular part of the paper, or people who were very keen to write up a whole manuscript based on the results, so it was very enriching and very good for networking, as I mentioned earlier. So I believe in that. Whether this can be done in a more efficient and less costly manner by having people connecting remotely, I guess that is something to be discussed. I don't think we can undermine the importance of face-to-face interaction, especially when it comes to finalizing a very particular research question, getting into the detail and finalizing lists of codes, and that was quite an intensive exercise.
Yeah. Yeah, the code lists, so what codes you're actually using is very important, right? So I came to Odyssey a couple years ago, more with a background in computer science and then bioinformatics. And I think the two elements which struck me most, which weren't initially apparent to me, is how important time is. Like everything that you're doing is time-based, and the whole OMOP model, everything has a date, and you're always looking at before, after. So that's a very interesting and important element. The other one is, I was just amazed when we came into the EMF project that people could spend hours debating which code to use. I thought, you're looking for people with diabetes, right? That's a simple database query. Just select the people with the code diabetes. So maybe it's good to, either with the study-a-thon or in general, explain a bit more to the audience how that works.
Yeah, so there are two very valid points. So I guess time is an obvious one. I think when I teach, undergrad students about epidemiology or basic statistics, and you teach them about survival analysis and the importance of taking time into account in your analysis, I always tell them the example of death. So death is something that will happen to all of us.
Yeah.
I really mind. I really want to live longer than shorter, right? So, when it comes to death, it's all about time. It's when are you going to die? That's what matters, not whether you're going to die, because we are all going to die. When it comes to the codes and code lists, that is indeed one of the points, I would say, in the whole exercise where you need clinicians involved and you need data knowledge. So you need to know what kind of data you're using. You need to know, whether people have been, let's say, clinicians who contribute data have been using or have been encouraged to use some particular codes. So, for instance, in the UK primary care data sets, we have this thing called QOF, where GPs are paid a little bit of an incentive if they do certain things. So, for instance, controlling certain parameters in people with diabetes, and that will, of course, cause some coding practice, right? So that is something very specific to that data set, but other things, similar things will happen elsewhere. And all those things you need to know inside out before you can put together a really valid list of codes that will work in all your data sets.
Right. Yeah, it sounds to me like here a major thing is to really understand your data in order to do the analytics. I think that's a theme also with FAIR data, because today there's a lot of interest in machine learning, and we also have patient level prediction in Odyssey, right? But first you need to have clean data and understand how you came to be. I mean, it may not be as clean as you wanted, certainly not in observational research, but at least understanding the context is extremely important. Yeah.
Absolutely. Yeah.
Yeah, we're also getting questions on EHDEN. I think that in the next EHDEN webinar, Peter and Nige will go in detail about what we are actually planning to do. But what is important to know is that EHDEN has the ambition to build a European network of data sets. It will be open. So we'll be welcoming any data sets that wants to, let's say, advertise themselves in a network. And they will be able to supply some of this context that I was just talking about. In FAIR, we call that metadata. Things like what are the inclusion exclusion criteria of the cohort, what are the variables or measurements that you have in your GP database or registry or EHR or pharmacy records or whatever the healthcare data source is. The other aspect is that EHDEN will be a network where studies can be conducted, and this will actually be in an open manner. The last thing I want to say, because I think if you want the details, please tune in to our webinar. But we will be providing training, support, and really helping out also with money to make sure that we can do this in Europe, so that databases can map to OMOP, etc. Yeah, so Danny, there's some questions about the methods being used. Maybe it would be nice to quickly show where you publish your results and how that looks like.
Definitely. So if you are interested, I would prompt you to probably when we finish the webinar, so you don't get too distracted playing with the data, to visit the website where the colleagues from Johnson & Johnson and the people who did the study-a-thon put the results and the protocol and everything. And you have here, the first one is about comparing the results of partial and total knee replacement, and the second one is about prediction. And if I may still try to do this live, and this is where we are playing high risk now. So yeah, this is basically the results from one of the questions we were looking at, where we were comparing, as you can see here, unicompartmental, so that would be partial knee replacement with total knee replacement, with the outcome being revision surgery, which is basically a new surgery of the same prosthesis, either to retrieve it or to replace it. We use data from 5 data sources from the US and the UK, as you can see here. And if you click one of them or unclick, that will disappear from your results. So it's all interactive. And then if you want to then play and click into this, you can see your results in terms of power. So how many people had the outcome of interest, how many people were in each of the cohorts. You can see an attrition table. You can see your population characteristics. Just to look at comparability before and after propensity score matching, this method that I mentioned earlier to minimize or to create balanced or similar groups of patients. You can see the distribution of your propensity scores. You can then look at the covariate balance. This is a plot that I particularly like because it's interactive, and you can hover over it and see what are the variables that were imbalanced before matching, and so on and so forth. We have this really nice feature of systematic error and using negative control outcomes. The colleagues from OHDSI have created this set of analysis that help you understand whether there is a kind of systematic bias or something unmeasured in your data. And finally, in here, your Kaplan-Meier plots. And then on top of the screen, you can see the results in terms of hazard ratio, so relative risk, if you like, before and after calibration for an observed confounding or for negative control outcome error. And you can see in this particular case, we found that partial knee replacement compatible with previous data led to a higher risk of revision surgery, which is the, as I mentioned, in 5 years' time. And you could then, if you click here later and want to look at it, you could look, for instance, at venous thromboembolism, which is a blood clot that happens usually soon after surgery. If you look at 60-day results, for instance, and it's all, again, interactive, you can see how this was lower in the people who received partial knee replacement. Again, reinforcing previous data that partial knee replacement is a little bit safer than total knee replacement.
Right. So you mentioned in the study-a-thon that you looked at the question from the Topcut trial, which is about these various methods of knee replacement and which one is more suitable. But then now here you're also looking at the other outcomes, right?
Yeah.
So these are complications that could arise, and you're actually comparing one method, unicompartmental, versus the other total,
Yeah.
and looking at the complications and really seeing a difference. But so here you're looking at one data source. Is it very different in other data sources? I mean, could you?
Yeah, so if you go on the left-hand side of the screen, you can see where it says data sources. You have 5 data sources we used. I've now clicked the 5 of them, and that gives you a result for each different data source. So you can see in CCEAE, for instance, you have about a, I guess, 25% reduction in risk. In Medicare, we have more than a 50% reduction. Optum has a 30% reduction. Thin didn't have enough power for this particular outcome because venous thromboembolism is not that common, and Pharmetrics had a 40% reduction. So in this particular outcome, this particular analysis, there's very consistent findings from the 4 databases that had access to data on this particular outcome and with enough power to conduct this analysis.
Right. Yeah. Okay, I'm sure we could spend a lot more time going into the details of this.
I'll just show you something that I think is very relevant here for the FAIR principles that you mentioned. If you go to the About, or actually this is where the website will log you in, there's here the whole protocol available for everyone if they want to check everything exactly as we did it, and also the whole full source code, so that people who have mapped data to OMOP can actually download the code from there and replicate the whole analysis in the data set. So that, I think, is again a game changer in the field of observational research.
Yeah. As I understand it, there's actually quite a bit of methods development going on as well in the OHDSI community.
Absolutely, yeah. I think there's a lot of methodological expertise in the OHDSI community, and a lot of people doing really great job at putting together, analytical pipelines and tools to do this kind of analysis as well as others. We didn't discuss because we don't have time the prediction modeling bit, but that's also a very interesting bit of work that we did during the week.
Yeah. By the way, people are asking about how they can find more information on EHDEN and on OHDSI. So the OHDSI website, OHDSI.org, is a good place to go, and also the EHDEN website, which is EHDEN.eu. EHDEN spelled as you can see in the screen. In fact, the OHDSI community, together with EHDEN, is organizing a meeting tomorrow at Erasmus MC, and also in a weekend with tutorials, which is the OHDSI Europe meeting. And so we may actually see some of you there tomorrow. And if you do have other questions, please feel free to approach us and talk to the people from EHDEN. There will be talks. I think you're also giving a talk, right, Danny?
Indeed, yeah, I am.
What is it about?
So I'm talking about the bit that we probably didn't cover very much in this webinar, which is characterization. So basically looking at, how do we use these data to look at treatment patterns, who uses the medications that are there in the market, drug itineraries, and characterization in general. So I'll be covering that in the morning tomorrow.
Great. There's actually, I think, a burning question about whether you're using Bayesian methods in observational research.
Well, there's people who use them. We have tried some in my team. We didn't use them in this particular study because that was not part of the protocol that we wrote. But I don't have any problem with the use of Bayesian methods. So yeah, it's an interesting, I guess, methodological piece of work that could be done using Bayesian methods.
Yeah. So maybe to recap, one aspect which is also what EHDEN is working on is that we are putting together the standardized model, the OMOP Common Data Model, and helping databases to harmonize in that, so that we can actually use then the OHDSI tools to do large-scale research. And I noticed that if you go into the OHDSI meetings, people are careful to say that it's large-scale medical evidence generation. So not necessarily like machine learning or, but rather the careful application of statistical methods to databases coming from various parts of the world in order to answer these questions.
Yeah, and I I have, I guess, my own toolbox. My research team has a toolbox with a lot of methods that we use for different questions. I just don't believe that we need to get stuck with a particular set of tools. I think we need to develop tools that work for different research questions, and there's probably one or two analytical tools that work best at answering a given question, right? So I think the current toolbox in OHDSI is brilliant already, but I'm sure that within EHDEN we will have opportunities to enhance that and to collaborate with OHDSI to bring other tools to the common data model and to make them available and open source to the community.
Right. By the way, to the audience, if you have ideas about future topics that we should cover in the EHDEN webinars, please tell us about it. We'd be happy to cover, for example, I think going into methods is an important one, going into the regulatory perspective. So we have a number of other facets planned. I think here the open science angle in particular was very interesting to see. And I hope that we will be able to organize more study-a-thons and get this going. When you look to the future, maybe I guess in the last few minutes that we have, one important aspect of EHDEN is actually bringing data which is currently not easily accessible. Because if you have enough money, let's be honest, you can throw that at a problem and you can reach Medicare, Medicaid, Optum, so US claims databases. You can also have CPRD, and some of these databases are available. But there are many data sources in Europe which aren't necessarily and also will never be available unless we have a model like OHDSI, right?
So I guess that is one of the key advantages of EHDEN is the approach of a kind of federated network where people who are not allowed or not willing to share patient-level data, as many colleagues cannot do in Europe, have the opportunity to join a network of people who are doing research together, to map to a common data model, and then to reuse analytical tools and analytical code in a, at a large scale. That is indeed one of the advantages of this approach.
Right. And if you think ahead, how do you think that if we had the complete EHDEN setup, so we had a federated network, sophisticated around Europe, we had multiple countries mapped, how could it impact your work or the field in general?
Well, I think there are many stakeholders that will be delighted with that. Me, of course, because of my clinical background and because of my methodological interests, but also, I guess the regulators would potentially have access to much faster results on any particular, safety concern, for instance. They could get much quicker findings on the use or the utilization of a given product in the European market with the different, healthcare settings around Europe and being, in a way, represented in these studies. So I think it would be a game changer. Yeah.
Right, yes. Yeah, the EMA actually did a deep dive on common data models, right, which was again also end of last year, and which you can find on their website. Hopefully we do get a chance to cover that as well in some of the next webinars.
Definitely, hope so.
So I think we're almost nearing the end of the hour. Is there any last insights that you would like to share with us, Danny?
Well, I'm really looking forward to the collaboration with the colleagues who are in the call within EHDEN and out of EHDEN. But I'm really looking forward to Peter's and Nigel's presentation in the next webinar to learn more about the detail behind EHDEN, how we're going to be working together, and all the processes that will be put in place to make this come to life. Because I think, as I said, this is going to be fundamental for improving and the transparency, the reproducibility, and the quality of the observational research that we do in Europe.
Right. Okay. I think with that, I would like to thank everyone that tuned into this webinar. Be sure to monitor our website, ehden.eu, for future announcements. As I said, the next one, which will be coming online soon, will be on April 10. And look forward to see you there. Bye for now.
Thank you.